Okay, hello everyone. Let's get started with today's problem. Minimum operations to exceed threshold value 2. Okay, so you are given a zero indexed integer array and integer k. You are allowed to perform some operations on nums array, where in single operation you can select two smallest integers x and y from the nums, remove x and y from the nums, and insert minimum of xi times 2 plus maximum of x comma y at any position in the array. Note that you can apply the described operations contains at least two elements. Return the minimum number of operation needed so that all the elements of the array are greater than or equal to k. So we have few test cases here, and the constraints are the size of the array is 10 power 5, and number lies in the range of 10 power 9, 1 to, and k lies between 1 to 10 power 9, and it is also guaranteed that the answer is always exists. Uh, so question says we will be given an array and in a k. So what we'll have to do is we have to do a certain operation. We can do as many times we want. So such that after the operations, uh, all the values in the array are greater than or equal to k. So to do that, what is the minimum operations we can do such that we will be having the array that is having all the values greater than or equal to k. So it is always better to pick the smaller elements first instead of larger elements. So if we pick the smaller elements and do the operation, and if it becomes greater than k, we can discard those and we can process the remaining elements in the array. So by if we are greedily doing this, we can get the desired value. Uh, why can't we pick the maximum elements instead of minimum elements every time? Let's say there were, if we pick the maximum element, let's say, and these two are uh, let's say there were three elements and two elements are less than k and one element is greater than k. And if you pick two maximum elements, then one of the element is k, uh, greater than k or equal to k. Then we will be wasting one operation there. Uh, so let's say we have two numbers, 1, 2, 4, and k is equals to some 3. If we pick the maximum instead of minimum, so we will be doing one operation for this one and another operation combine this one. So it will always greedily pick the minimum instead of maximum. So every time we need a minimum element, so we need a data structure that can solve efficiently in maybe we can use min heap for that. So what we can do is we will keep all the elements in the heap and we'll keep taking two elements out of it and do the operations. Uh, and we'll keep inserting into the heap. We will be doing until the heap is empty. And so let's try to solve this uh, until we reach k. So when we can stop is if we if the top element in the heap is greater than k, then we can stop because all the other elements are all for sure greater than k because it is a min heap. So the minimum element is already top. So we can stop there and return the minimum operations. So let's get start coding the problem. So I will be defining. So we need a min heap. Uh, so while one thing we have to make sure is while we're doing this operation, let's say the value is 10.9 and we are doing like some x times, then it will go, there is a chance of overflow. So it is better to use long instead of integer. Now what we can do is for each num, we'll just keep the nums into the queue, like in the heap. So since this is an integer, so we will be typecasting to long. Let's do it as well. Now, when can we uh, if min greater than one? So at least we need two elements in the array to do the operation. So till the size is greater than or equal to one. So we need minimum operations to calculate. Initially it will be zero, and we will be returning. Mhm. So we will try to take two elements out of it. I mean, hey, since the greater than one, for sure there will be more than two elements. So we will be taking out two minimum elements, and we will be adding minimum of two times max. So this is the operation they want us to do. So we will be doing one time. So before we do this operation, if minimum is greater than or equals to k, we need to stop the this loop because by this time all the other elements are all greater than or equal to k for sure. So I think that's it. So the time complexity will be like here it will take n time. So we will, usually what it will do is it is not the best way to do. We will add all the elements into the queue and we heapify and it will take linear time. So let's say this will take a linear time. Usually this will take n log n time. But if we do add all and do heapify, then it will take n time. And this loop will run, let's say, size times. And each time what we are doing is logarithmic operation or adding here. So the overall time complexity will be uh, n log n, big of n log n. And space complexity will be like we are using an extra heap which can store n elements. So other than that, we are not using any space. So it will be big of n. So I think this will work. Let me run sample cases. So it is running. Yes, fast. So okay. This falls under heap and greedy category. And that's it for today. Thank you for watching the video and please feel to subscribe. See you.